We talked about exponents a couple weeks ago, and then a couple months ago, and then a couple weeks ago again, and a couple days ago, because we talk about them all the time, right? But back when we made our exponent foldable, on the very last page, hopefully your last page looks something like this. Yes? This is what we really need to concentrate on today. Okay? We need to remember that when we have a fractional exponent, or also known as a rational exponent, in our exponent, the numerator is the power and the denominator is the root. You okay with that? So let's do some examples of that so you know what I mean. And then we can get to the equations for today, or examples for today. If I say 8 to the 1/3 power, what does that equal? Well, the top is the power and the bottom is the root. Do we know the cube root of 8? Close. 2, right? Cube root, remember, is what times what times what equals 8, right? And that's 2, right? So the cube root of 8 is 2. Now, what I just said was cube root, and what it really says is 8 to the 1/3 power. So does it make sense to you that the 1/3 power is the same as cube root? Yeah? Okay. So what if I said 8 to the 2/3 power? If the numerator is the power and the denominator is the root, what is the cube root of 8? 2. And then what's 2 squared? 4. Now, could I punch this into my calculator? Yes, you could, but you know how much I like you guys to be able to do stuff with your head if you can, right? I'm not saying you can't do it in your calculator. I'm saying it will be faster sometimes for you to do in your head. Not all the time. Not all the time, but sometimes it will be faster to do it in your head. Okay, so tell me what 8 to the 4/3 power is going to be then. Well, what's the cube root of 8? 2, and what's 2 to the 4th power? 2 times 2 times 2 times 2. 16. What if it was 9 to the 1/2 power? The numerator is the power, the denominator is the root. Yeah, absolutely. First power is just itself, right? And then the bottom is the root, in this case a square root. What's the square root of 9? 3. What is 9 to the 2/3 power then? How about if I write what I meant to write, which is 3/2? Sorry about that. Let me start that over. 3/2. What's the square root of 9? 3. And what's 3 to the 3rd power? 27. Does that make sense? Okay. So here's where we're going to go with that. I'm going to say to you, x to the 1/2 power plus 3 equals 9. Where did 3 and 9 come from? Well, that's just given to you. That's part of the problem. I don't want you to think just because we just did a bunch of problems, examples of 3s and 9s, it has to come from somewhere. That just happened to be what I wrote down. Okay? How do I solve this equation? I have to isolate the part with the well, in this case, I want to isolate what I'm trying to solve, right? In this case, it has the exponent with it, so I got to isolate this term. How do I isolate that term? Subtract 3 from both sides. Once I subtract 3 from both sides, I have x to the 1/2 equals 6. How do I get rid of a half as my exponent? What'd you say? Where did you get that number? How is it related to this number? It is the reciprocal. Okay, I do want to multiply the exponent, not the side, not the number. I want to multiply the exponent by its reciprocal. Well, if I do it to one side, what else do I have to do? To the other side. Now, am I saying 6 times 2? No, I'm saying 6 to the 1st power, and the 1st power is being multiplied by 2 over 1. The power is, right? I'm raising both sides to that power. Okay? So what happens to my exponent on this side? It becomes 2 over 2, which is 1. If I get anything else than besides what's being raised to the power, I did something wrong, because I did the reciprocal for the sole purpose of getting rid of the exponent. Okay? What happens on the right-hand side? What's 6 to the second power? 36. Is it right? 36 to the 1/2 power. 6 plus 3? 9. It's right. What about if it looks like this? Oh, that's too many 4s. I'm going to make this a 5. Then I better make that an 8. X plus 4 to the 1/3 power plus 5 equals 8. That's exactly what I want to do first. Very good. If I subtract 5 from both sides first, that gives me x plus 4 to the 1/3 power equals 3. Now what? Can I subtract 4 from both sides? Why not? It's in the parentheses, right? It's part of the thing that's being raised to the power. Is what's being raised to the power isolated? Yes, then let's get rid of the power. No. 3 over 1 here, 3 over 1 here. Raise both sides to the 3rd power. Okay? What happens on the left-hand side? What am I left with? X plus 4 equals 27. Is that an equation you know how to solve? What's 23 plus 4? 27. What's the cube root of 27? 3 plus 5? 8. Can I show you why this seems so familiar to you? Do you know how to solve that problem? Yeah, we spent a bunch of time on this, right? We subtract 3 from both sides. We get square root of x equals 6. How do we get rid of a square root? We square it. X equals 36. Do you see why these seem so familiar? We've already done this. Now we have to do it where it looks like a rational exponent. These two things mean the same thing, don't they? Just a different way of writing it. But that's why this seems so familiar to you, because we've really kind of already done it. It just visually looks different to your eyes. Okay? So let's do this example right here. X to the 1/4 power plus 3 equals 0. What do I do first? Subtract 3. Seems pretty simple, right? Equals what? -3. Now what? Reciprocal, which is 4 over 1, or just 4, right? What's x equal? -3 to the 4th power? Maybe you can do that in your head, maybe you can't. Maybe you need to use your calculator for that. If we use our calculator, what do we need to make sure that we put in? Right? Okay, so what is -3 to the 4th power? 81. Any questions? Anybody see a problem? What did we forget to do? We didn't check it, did we? Okay. 81. What's the 4th root of 81? 3. 3 plus 3 equals 0. Except, I said what's the 4th root of 81, and we said 3, and that's the right answer. Is 3 plus 3 equal to 0? No, that's not equal. That one doesn't work. So is checking our answers really that important? Yes. Yes, it is. Okay. I did kind of let you know that there are some quadratics involved in this today, so let me show you an example of that. X plus 30 to the 1/2 power equals x. Is the term with the radical in it isolated? Our radical exponent's isolated, right? So reciprocal to both sides. Raise both sides to that exponent, right? What do I have left on the left-hand side? X plus 30. What do I have left on the right-hand side? X squared. What kind of problem has this become? Well, it's a quadratic, right? If it's a quadratic, I need to get it equal to 0 because there's an x and an x squared. If there was only an x squared, I could solve from here, right? By taking the square root of both sides. But because it's got an x and an x squared, I need to get it equal to 0. You guys know I like positive x squared terms if at all possible, so I'm going to move everything to the right-hand side. Well, luckily, what do you notice? If you're trying to solve this, what do you notice? Leading coefficient is 1, so you tried to factor. Does it factor? It actually does. Yeah. So x minus 6 and x plus 5. So we got lucky this time, right? Because otherwise, what would we do to solve it? Quadratic formula probably, right? So x equals 6, x equals negative 5. Should we check it? I mean, are you sure? Okay. So 6 plus 30. 36, square root of 36. 6 equals 6. Okay. Negative 5 plus 30. How about 25? Okay, 25. What's the square root of 25? 5 equals negative 5. No, it doesn't. Any questions?